Okay. Sharing screen. Can you all turn on your this thing cameras, please? Okay. Let's start with homework 3 discussion. Okay. First one, let me just paste it here. Okay. Ritisha, were you able to do this one? This logarithm question?
Yes, sir.
Okay. Can you, what did you get? And can you explain what you did?
So I got option A.
Mm-hmm.
So like for that, so after 2013, it has to be 3, max 4 for it to be option A.
Mm-hmm.
And then if you go inside, so 10 to the power 4 is 10,000. And then you do 10,000 minus whatever, so you get roughly 8,000. But then it goes to 10 to the power 8,000, which is very big. So that level comes, I chose A.
Exactly. Yes. So, yeah. So I approach it from this way, but you started approaching it from this way, either way, right? So log 2, let's say you're dealing with base 10. Log 2 approximately, you guys should know, approximately 0.3, right? So how do you know log 2 is 0.3? So you can just say 2 power 10, which is 1024, is approximately 10 power 3, right? So which means 10 log 2 is 3 log 10. Therefore, log 2 is 3. I mean, I'm just saying approximately. So 2 power 10 is 1024, which is approximately. So this is useful in case you want to go back and forth between any two numbers with logs. Just find the closest power of 10 to connect them. Okay, so this is going to be log of 3 plus such a small number. Just 1 second. Okay, so this is log of 3.3. Okay, and then we have 4 plus log of 3.3 here, right? Log of 3.3 again is a number which is substantially less than 1, right? So again, I remember some of these values. I find it easy. So log 3 is around 0.47, and log 5 and log 2 should add up to 1. So log 5 is approximately 0.7, right? Log 5 plus log 2 is log 10, which is 1. So for this exercise, so log 3 is also such a small number, log of 3.3. Therefore, 4 plus a small number, which is maybe 0.5 or something. The idea is whatever number you're adding plus the log of the rest. The log of the rest is going to be such a small number. Log is a very, very slow moving function. If I plot log goes like this, right? So, which is why they have aptly named it log, as in like a log, right? It's hardly raising up. It's very flat. Okay, Arnav, Rahil, why is the camera still not on, guys? Please, Sumair, all of you. Okay, so now back to what she was saying. So that means all of this can be approximated to be much smaller than 2012. So this is 2012 plus some change. Let's call that change as whatever X or something, right? But X is going to be substantially less than 2012, right? And therefore we have log of 2012 plus approximately X. So log of 2012 plus X is approximately log of 2012. But even assuming this X is substantial, so log of 2000 is in between log of 2012 is in between log of 10,000 and log of 1,000, right? Therefore, this guy is between 3 and 4, right? So, and even if this extra X that we have is, even if it's substantially big, even as big as 7,000 or 8,000, it's still going to be between 3 and 4, which means effectively the given problem is going to have log of 2013 plus some change, which is 3.xx. So which means it's going to be between log of 2016 and log of 2017. Yeah, I mean, that's the best approach. The main idea here is log is a very slow moving function, and some basic approximation. Either way, you can start from left and go to the right, or right to the left. Either way. Is this clear to everyone? Arab, you're clear on this one? Or did you do similar, or were you able to do this?
I didn't get this.
But does it make sense?
Yep, it does.
Okay. Okay, Sumer, Make sense? Okay, cool. So that was question 1. Question 2. Yeah, Anika, were you able to do this question 2?
Yes.
Okay. What option did you get?
So I got A.
2 minus 2 root 2. Okay, anyone agree or disagree with her? Oh, in fact, I sent out this thing, right? The answer sheet, right? Didn't I? Okay, yeah, it is A, it says. Okay, anyone else matches her answer?
Then I got A.
Got A. Okay, cool. Manan, how about you?
So even I got A.
Okay, nice. Let's discuss for people who might not have got still. So, so this is, let me plot this x-axis and y-axis. So it's let's approximately find out in which range each of these values will lie. So it's in the second quadrant and in the bottom half of the second quadrant, right? So bottom half of the second quadrant, I think below the 135-degree line and above the 180-degree line. So cos x is negative and cos square x is positive. So let's say I mark the number 1 is here, 1 is here, 1 is here, and 1 is here. Okay, so cos is going to be some negative number close to 1, and then cos square is going to be some positive number numerically less than 1, right? So let's say the first point is P is here. So this is P. And then Q is cot x. Cot x is negative in the second quadrant, and it's numerically bigger than 1, right? So bigger than 1. So I'll just put, how do I know it's numerically bigger than 1? Because it's flatter than 45-degree, right? So if something is steeper than 45-degree, tan is bigger. If it's flatter than 45-degree, cot is bigger. Adjacent side becomes longer, right? So cot x is negative, and then cot square x will be a huge positive number, relatively speaking. Therefore, this is, no, not huge. It's a cot square x will be bigger than cot x in magnitude. So let me just draw the 45-degree line here, just for, let's say the 45-degree line is here. I mean, it's not necessary, just for reference. Let's say 45-degree line is somewhere here. That's the 135-degree line. So P is here, Q is here, and then R, which is sin x, is going to be a number which is a positive, and sin square x is also positive in the first quadrant, and smaller than cos x in magnitude, right? Because it's less than 45-degree, as in the reverse is more than 135. So it's a shallower angle close to the x-axis. Therefore, sine is going to be numerically smaller than cos. Again, all of this is not necessary. As long as you roughly plot, it's fine. So just to get an idea. So PQ, the only reason I'm doing that is I just want to see which are the two parallel sides. As long as it's fairly obvious, it should be fine. So S is tan x. Tan x is a positive number. Tan square x is also a positive number. Tan x is a negative number. Tan square x is a positive number. So that will probably be somewhere here. Let's say PQRS. Okay. Okay. So roughly, it's coming this way, right? The trapezium is that this guy and this guy are parallel sides. Of course, I haven't drawn perfectly, but I don't think there's any other way in which you can connect it. And they typically give it in the same sequence. When they say PQRS is a trapezium, it should be in that order. So it's just a question of connecting the slopes of PS and connecting the slopes of PS and RQ. So let's write out the slope of PS. So I'll go with P first, and then so cos x or cos square x minus cot square x upon cos x minus cot x. That's the slope from PS. Tan x, right? P and S as tan x. Sorry. If I do some mistake, please stop me, guys. So PS is cos and tan. So this is this. And then QR is connecting cot and sine. So sine square x minus cot square x upon sine square x upon sine x minus cot x. So effectively it becomes cos x plus tan x equal to sine x plus cot x. Okay, let's write everything in terms of sine and cos. That's obviously the easier way, right? So cos x plus sine x by cos x equal to sine x plus cos x by sin x. So what do we have? I have cos square x plus sin x. Am I right? Equal to sin square x plus cos x. Okay, upon cos x here, upon sin x here. So what do I have? I have cos square x into sin x plus sin square x equal to cos square x plus sin square x cos x. Am I right? So let's see. How do I simplify this, guys? I can take this guy and this guy to the left side. So cos x sin x into cos x minus sin x equal to, if I take these two to the other side, it becomes cos square x minus sin square x. So it's cos x minus sin x into cos x plus sin x. Cos x plus sin x. It's a simplification, nothing much, cos x plus sin x. So I know that cos x minus sin x cannot be 0 because cos is negative and sin is positive in this quadrant. Therefore, I have cos x plus sin x equal to cos x sin x. Okay, so now I have established relation cos x sin x equal to cos x plus sin x. Now what do we want? We want sin 2x. So sin 2x, sin 2x, I can leverage 2 sin x cos x is sin 2x, right? So sin 2x is 2 sin x cos x, which means, okay, so I want this. I want sin 2x, which is 2 sin x cos x. So I can maybe square, I can square this equation, I can square both sides, and I can give cos square x sin square x equal to cos square x plus sin square x plus 2 sin x cos x plus 2 sin x cos x. And then I can treat it as a variable in terms of what I'm solving. So let me keep sin x cos x as t, and then I have a quadratics, right? So let's say sin x cos x is t. I have t square minus 2t minus 1 equal to 0. So this becomes, t becomes sin x cos x, which is minus b plus or minus b square minus 4ac whole upon 2a. Okay, and we know that sin x is positive and cos x is negative, therefore we expect a negative answer. Therefore it is 2 minus root 8. Root 8 is 2 root 2 upon 2. So it's 1 minus root 2 is what? Is t. But I want 2t. Therefore the answer is 2 minus 2 root 2. Was that the answer? 2 minus 2 root 2? Yeah. Okay. Could I have done anything better in terms of simplification, or did you guys also have somewhat elaborate simplification? Anika, what did you do? Very similar?
Yes, sir.
Yeah. Okay. All right. So, I mean, ultimately, you'll get to a point where cos x sin x equal to cos x plus sin x. After that, squaring, and then this much amount of simplification is expected, guys. So don't get frustrated if it seems like heading towards some vague direction, right? Just be careful, and then it should simplify. Yeah. All of you good? Rahil, you're okay on this one? Arnav?
Yes, sir.
Okay. Arnav, Sumer, please, camera on, please, guys. I want to see all of you throughout the class, please. Question 3 was an interesting one. I want to highlight.
Is it fine if I have my camera off this class?
Why so?
Because my network's a bit glitchy. I barely connected to the meeting. That's why it took me a few minutes to join the meeting because it wasn't working.
All right. If it's indeed that's the case, then fine. Okay, it's okay. All right. In triangle ABC, was anyone able to get this one? Rahil, were you able to get this one?
No, sir.
No. Okay, Ritisha, how about you?
So I got this.
Okay. Briefly, can you describe what you did?
So first I reflected C across AB, and then I reflected B across AC. And then for it to be the shortest sum, all of those points have to be collinear, and then you have that application of law of cosine, and then you can solve it.
Yeah. So whenever, that's very good. So whenever they are trying to minimize some lengths in geometry, we can use the triangle inequality. Triangle inequality is nothing but if you have two sides of a triangle that's bigger than the third side. That's a triangle inequality. And that holds good, extending it also. For example, if you have a quadrilateral, if I have three sides like this, not necessarily a trapezium, it looks like this. Okay, so if I have three sides of this, so the sum of the three sides will exceed the third side. So sum of three sides will exceed the fourth side. A plus B plus C will exceed D. Okay, so a big clue is whenever you're trying to add a few values, you try to establish a line, right? Or rather, when I illustrate this, it'll be clear. That's exactly what she's also saying. So I'll illustrate it with the diagram, so it will be clear. Okay, so let's draw a reasonable picture for this. So this is AB. AB is 10. So AB is 10. Okay, and AC is 6 at 40 degree. So this is 6 at 40 degree. Let me just draw approximately 40 degree. Okay. And now let's mark all of this. So this is A. This is sorry. This is A. Yeah. So this is A. This is B, and this is C. Okay. D and E lie on AB and AC respectively. So randomly, let me put AB is this and AC is this, right? So let's say D is somewhere here and E is somewhere here, doesn't matter where. So D and E are on AB and AC. What is the minimum value of BE? Let's correct all of those points. So BE, okay, I'll give different colors for all of them. So BE, DE, so DE, and CD. CD, I'll just give another color here. So CD. Okay, so the sum of these three must be minimized. Okay, now again, so this is like almost like pulling out of rabbit out of your hat types. But if you do a few of these kind of problems, you'll see that this is a very commonly used reflection principle. So if I reflect around, so I know this is 40 degree, right? So I know this is 40 degree. 40 degree. Okay, so let me reflect a line around this. So I'll draw a line this way. Okay, now I know that AB is, what do I know? I know AB is 10. So I have to mark that also, right? I know AB is 10. So this is 10 units and this is 6 units all the way from A to C. So let me mark a corresponding C, which is a reflection of C. So let's say this is C2, okay, which is a reflection of C1, the original C. Okay, so that will also be 6. So since everything is reflected, all the lines will be symmetric around it. So this is, instead of CD, I can just effectively compare it with CD is same as C2D. Okay, or maybe instead of C2, I'll just call it C dash. So C dash D. So CD is same as C dash D. Okay, so this is C dash. Okay, now what am I doing? So I'm adding, what are the three things I'm adding? CD, DE, and BE. So now I've brought CD here. So let me just mark CD here and DE here. So I want to have a contiguous line. So C to D, D to E. I want to have E to P as another line, right? So that I can add all three of them. So now let me reflect a 40 degree line around AC. So this is, I'll put a 40 degree line this way. So 40 degree line, does it look more like 40 degree? Yeah, this looks 40 degree. Now, just like I reflected AC around the line AB. Let me do the reverse. I can reflect AB around AC. So which means this is my B dash. So this is my B dash. So this is B dash. So this is B and this is B dash. So which means if I connect from here to here, yeah, this is definitely a more difficult question, but as long as they're able to follow, that's good. Okay, so this is my EB dash, right? So what am I trying to add? I'm trying to add my original question is EB. So instead of EB, I've replaced it with EB dash. So I've marked these two. And then DE, I've kept it same. DE is just DE. Okay, DE is just DE. And instead of CD, I've kept it as, instead of CD, I've kept it as C dash D. So what have I done in this case? Now, so CD has been replaced with C dash D. DE has been kept as just DE itself. And then EB has been replaced with EB dash. So C dash D, DE, EB dash is like a route that's going this way. If you look at this route, it's like this. And then this is winding here, DE, and then EB dash like this. Now, if that route has to be the smallest, then that line better be a contiguous line. So the D and E, if they're randomly chosen, it'll end up a path like this. But if they are so chosen such that C, D, E, and B dash all lie on a same straight line, or rather C dash, D, E, and B dash all lie on a straight line, that will be the smallest length of this sum. Is this clear to everyone? I'll pause here. Rahil, is this clear to you? What I'm describing? Manan, you're with me?
Yes, sir.
Okay.
Yes.
So yeah, so in the eventual picture, how is it going to look like? So it look like A, B dash will be here. So I'll just draw with the same color. A, B dash is going to be like this at the top. And then AC is going to be this in this angle. So this is my A. This is my C dash. And upar, this is my B dash. Right? And this, instead of a curved line like this, I'll have a perfect line which goes from here to here. And now I can just apply cosine rule to find the length of this one. So this is 10, this is 6, and this is 40 on this side and 40 on this side through a reflection. Okay, I absolutely don't expect you to do this at all, especially during an exam situation. But the more you learn these type of tricks, slowly you'll start to apply them in a somewhat simpler questions. As long as you understand this, at this point, I'm happy. As long as you understand the principle of reflection, that's good enough for now. But yeah, do think about it and try to solve on your own later. Now it's just a cosine rule, right? 10 square plus 6 square minus 2 into 10 into 6 into cos 120. Cos 120 is minus half. So whatever that works out to 100 plus 36 plus 60, right? Which is 196, which is 14 square. So that's the smallest length. 14 is one of the choices. Yeah. Is this description clear? Sumay, did you understand this fully?
Yes, sir. Yes, sir.
This reflection and how I mean converting to equivalent lengths. Okay, cool. Question 4 is relatively easy. Sumay, were you able to do question 4?
So 1 second.
How many positive integers is this less than 2?
So I don't think I did the right method. Like I just took a sort of a calculator guess.
Solved using calculator? What did you
No,
say? I
so,
didn't.
like I took an educated guess.
Okay, but all of these numbers are fairly close. I mean, except 10, 18, 19, 20 are all fairly close. How do you take an educated guess? And what was that guess?
So I guessed it'd be either B, C, or D. And
Because
then,
all of the numbers are fairly close.
not really, like I don't remember how I did this, but
All right. Anyone else? Rahil, how about you?
Oh, yes, I got B.
You got B. Okay. Yeah. So law was that the right answer as well in the answer sheet?
Yeah, it is.
Question 4. Yeah. B. Okay. So log of this is just log of the product, right? X minus 40 times 60 minus x. So this should be less than 2, right? Which means if I multiply, I get minus x square plus 60x plus 40x, so plus 100x minus 2400 is less than 100. Is it right? Less than 100. Okay, so x square minus 100x plus 2500 is less than 0. Okay, so which means x minus am I right? Is less than 2x is greater than 0, right? When you simplify, when you put it to the side, is greater than 0. Therefore, x minus 50 whole square is greater than 0. Okay, which will hold good for all values as long as x is not equal to 50. We should be fine, right? We should be fine with any number as long as x is not equal to 50, which is why one of the choices is infinitely many. But the trick here is we cannot have this quantity x minus 40 be less than 1, less than 0. Or rather, x minus 40 must be strictly greater than 0, which means x must be greater than 40. Only then you can take a log. Similarly, 60 minus x better be positive quantity. So 60 minus x better be greater than 0, which means x must be less than 60. So and given its integer, so the values are 41, 42, all the way till 59, except 50 in between. So 50 is ruled out. So 41 to 49, you can add 9 of them, and then 51 to 59, another 9 of them. So 18. Yeah. So fairly easy question. Okay. So that was question 4. Question 5. Anika, were you able to do question 5?
Yes,
Okay. Well, what did you end up getting?
I got A.
A. Okay. Isosceles triangle T and T dash are not congruent but have the same area and same perimeter. So the perimeter is what? 5, 5, and 8. So 5, 5, and 8 looks like this, right? So 5, 5, and 8 is this triangle. 5, 5, and 8. So we have a 3, 4, 5 triangle like this. So this is 3. This is 4 each. 4 and 4. Okay, so this is the 5, 5, and 8 triangle. This is triangle T. Now, what is the perimeter? Perimeter is 18. Okay, now we can imagine another triangle with the same area and same perimeter, but it's going to be like a steeper. So a triangle, something like this. Okay, so something like this. Now, this has to have the same perimeter. So let's say the lengths are A, and B. So this is A, and this is B. Okay, so what do we have? So we have 2A plus B should match my 18. So that's the first constraint. And the area must match, what is the area of this? Half into 8 into 3, which is 12. So half into B by 2 is, sorry, half into B, which is the base. And the height of this would be, so the height is, just by Pythagoras theorem, is square root of A square minus B by 2 whole square. A square minus B by 2 whole square. Okay, that's the height. Okay, so this must be equal to 12. Okay, so seems like a fairly simple calculation, but let's see. So 2A plus B. Okay, so we can convert. I can replace every 2A with 18 minus B. So 2A is nothing but 18 minus B, and I can see a 2A here, right? So where do I see a 2A? This is 2A the whole square, right? 2A the whole square minus B square upon 2 square. Okay, so half into B into this is square root of, let's do the simplification. It's important to do simplification well. So 18 minus B the whole square minus B square whole upon, I can bring the 2 outside of this thing, whole upon 2. 2A the whole square minus B square, 18 minus B whole square. Okay, all right. This should be equal to 12. So which means we have a b into square root of 18 minus, so this is, can we simplify this better? Let's see. So 18 square is 324 minus 36b plus b square minus b square gets cancelled, equal to 48. 48. Now we can simplify this a little bit, right? So I can take 36 common outside here. So 36 is 6. So 36 times 9, 36 times 10 is 360. Therefore 36 times 9 is this. So 9 minus b.
And the denominator, I was getting 4 in the root part of it. So it'll be 40 into 2.
48 into 2. How so?
In the root part of it, I was getting denominator as 4.
But that's inside the root, no? So outside the root, it's 2, right?
Oh, okay, okay.
Yeah. Yeah, it comes out. Okay. So this is b into root of 9 minus b should be equal to 8. Right? So we just have to figure out. So, and among the, what are the choices given? 3, 4, 5, 6. Okay, I'll just continue here. So b into root of 9 minus b must be equal to 8. So we can square this and say b square times 9 minus b should be equal to 64. Whichever works out closest to 64, we can go with that, right? So if we put b equal to 3, because it's a cubic, we won't be able to exactly solve. If we put 3, we get 9 into 6, which is 54. Okay, still quite far off from 64, but let's see how far the others are. This is 16 times 5, which is 80, which is quite far off compared to this. And then it'll only get farther, I think. So it's 25 times 9 minus 5, which is 100. So this is further away. Of course, we have the 8, right, which is the original triangle T. So one of the solutions, it's good that it's a simple sanity check. If you put 8, it should match, right? 64 times 1 is indeed 64. That's just a sanity check of my expression. B equal to 8 should be a solution because that's the same as the original T. But he specifically says the two triangles are not congruent, which means B clearly cannot be 8. And the closest one, therefore, is 3, right? So looking at the pattern, it will be somewhat between 3 and 4 because it's 54 here and it's 80 here. And my target is 64. But you don't need the exact value, right? Maybe around 3.2, but definitely closer to 3 than to 4. So some bit of approximation by hand is needed there. Okay, so conceptually not a big deal at all. It's just learning to simplify quickly and approximate. That's the main trick, right? Especially getting this part. I mean, how to go from here, right? Till here, everyone will arrive at, and after that, how to quickly approximate. Okay, so that was question 5. Yeah, question 6. Rahil, were you able to do question 6?
No, sir. I got the answer, but I wasn't able to visualize the graph. So
Okay. All right. So, okay. One very quick observation is visualizing the graph. Thanks for kicking it off. That's extremely important. Visualizing the graph is extremely important. Now, you can see that the graph, the left-hand side and the right-hand side are symmetric with respect to x and y. So if I have f of x, it's same as f of minus x. Why? Because anyway here it's x square. So whether it's positive or negative does not matter. And anyway here it's mod x. Positive or negative does not matter, right? And similarly with y also. So first observation, the graph is symmetric around both x-axis and y-axis, which means, let's say whatever picture this has, so let's say this is some picture, something like this. The same thing will continue on all 4 things, right? So I don't have to worry about what that picture is, but it's symmetric around all the 4 quadrants. That's all I know. So which means I can focus just on the first quadrant and make my life simple. So I'll just focus on the first quadrant and multiply by 4. And it's symmetric around all the 4 regions. Okay, that's first observation. Second observation is also that it's symmetric in x and y. F of x is same as, if I swap x and y, nothing changes, right? The expression still remains same, which means the graph is going to be symmetric around the line y equal to x. So the y equal to x, whatever way it behaves this side, the same way it'll behave. So it'll be maybe something like this is acceptable, but something like this is not acceptable, right? Because it's not symmetric. It should be symmetric around the 45-degree line. That's another observation. Okay, now how do you proceed from here? Now, since I'm in the first quadrant, let me just treat mod x is just x and mod y is just y, because it's first quadrant, x and y are anyway positive. So x square minus x, let me bring everything to one side, plus y square minus y equal to 0. And then whenever you have a quadratic like this with a quadratic in x square and y square with both the coefficients being same, it's a big hint, it's a circle equation. So a circle generally is what you might have seen this, x minus h whole square plus y minus k whole square equal to r square. If I don't know whether I covered it in class, but it's easy to visualize. Just like, let's take a digression. So if I look at x minus h whole square plus y minus k equal to r square, how will it look like? Or actually, let's simplify even further. Suppose we consider x square plus y square equal to r square. That's a simple circle around origin, right? So this everyone is able to visualize. It's just a simple circle around origin with radius r. Okay. Now, instead of x, suppose I call it x minus 3. And instead of y, I call it y minus 2. That means I'm shifting to the right by 3, and or rather to the positive x direction by 3, and to the positive y direction by 2. So which means the new center is 3, 2 and not origin. So effectively x minus 3 is the normalized origin. So this becomes 3, 2, and origin is somewhere out here. Doesn't matter. Origin is here. So x minus 3 whole square plus y minus 2 whole square equal to r square is radius, is a circle with center 3, 2 and radius r. Okay. Now this equation that we have up here is very similar to that. It smells very similar to that, right? So let's write it in that formula. X square minus, let's complete the square by writing 2 into x into half. Completing the square, all of you know, plus half square. So that brings us to x minus half the whole square. Similarly, very similarly, y minus half the whole square, right? And I'll add another half square to compensate here. I'm just completing the square here, guys. I'm adding the half square to match the x minus half whole square. So what does it become? It becomes x minus half whole square plus y minus half whole square equal to half square plus half square is how much? Half 1 by 2, right? 1 by 2. Half plus 1/4 plus 1/4 is 1 by 2, which is 1 by root 2 whole square. 1 by root 2 whole square. 1 by root 2, or if you want to visualize at root 2 by 2, that's fine. 1 by root 2 is approximately 0.7, right? Root 2 by 2 whole square, which means this guy in the first quadrant is a circle, but what sort of a circle? A circle with center at half, half, and radiuses of, so center is half, half. Let me just draw half, half. Half, half is the center. And radius is 1 by root 2, or rather half times root 2, which means the radius is, this much is the radius. This much is the radius, right? Are you guys able to visualize this? So the radius is, this quantity is half into root 2. Half into root 2. Okay, so if this is half, and this is half into root 2. So with this as the center and a radius of 1 by root 2. So the circle will pass through this. It will pass through 1, 1 clearly, and it'll be a picture like this, right? And it has to pass through this point also, right? Are you able to imagine this, guys? In the first quadrant, are you able to imagine this picture? All of you? Manan, you're with me?
Yes, sir.
All of you with me? Okay, cool. And now, and then it's going to be a symmetric picture along all the 4 quadrants. Now, finding the area of this is not difficult at all, right? I can see that this is a semicircle. This is a semicircle. And then this is a triangle, right? So this is 1 by root 2 and 1 by root 2. The radius 1 by root 2. So the semicircle area is pi r square by 2. And the triangle area is half base into base is 1, right? So the base is entire 1. So this is 1. From here to here is 1. Half base into height. So what do we have? Pi by 2, pi by 4 plus half. Pi by 4 plus half. This is 1 quadrant. And then therefore you have to multiply this by 4. Because every quadrant you're going to have the same picture. So it's pi plus 2. Was it the answer choice? Was it B, guys? 6.
Yes, sir.
6B, yeah. So pi plus 2. Does it make sense? Rahil, are you able to visualize this now?
Yeah, I got it. So thank you.
Right? How to exploit symmetry and all that. Okay, cool. So, and did you guys know the circle equation? Sumer, did you know the circle equation? X minus h whole square plus y
Yes.
minus k. Okay, all of you are okay. Ritisha, you're okay, right? You got this as well. Okay, so this was question 6. Okay. Question 7. The domain of the function, blah, blah, blah. So you have a series of logs here. So, so let's conquer. So what is the basic thing, when I have log of some quantity P, okay? So P must be bigger than 0. That's the main thing you should know, right? Strictly bigger than 0. And if the base is Q, in this case, we don't have to worry about the base because base is always given. But Q also must be greater than 0 and Q cannot be 1. These are the main restrictions with logs. Okay, so let's start from here. Right? So this quantity here, so I have, let me write it as a log of half, or rather log of P to the base half. There is this. So this entire quantity is P. Okay, so this must, so for this to exist, so this means if I'm able to do this, that means P better be greater than 0. That's the main restriction that I have. P better be greater than 0. Okay, so what is that P? So that P is log of some quantity Q to the base 4. So this is Q. So this is Q. Okay, so if this P, we want it to be greater than 0 from the previous step, that means Q must be greater than 4 power 0, which means Q must be greater than 1. Okay, Q must be greater than 1. Okay, but what is Q? Let me just erase P here and replace it with R. So this is Q. So this is, I'll just use another color. So this is R, let's see. So Q, which is log of R to the base 1/4. Okay, so that must be greater than 1. Correct? Am I right so far? So this must be greater than 1, which means my R must be less than, R must be greater than 1/4, right? Or is it less than 1/4?
Less.
Or, sorry, say that again.
Less than.
Lesser than 1/4?
Yeah.
Yeah. So for example, if R is 1/16, it becomes, if you're in doubt, you can just do it very simply. So this is, in other words, log R by log 1/4 is this expression, right? So, and then I can say this is log 1/4 can be replaced as minus log 4. So minus, if at all it helps. So if this is greater than 1, that means log R should be less than minus log 4, which means R must be greater than. So I'm making a mistake, guys. Sorry, what did I say? R must be less than 1/4, right? Or yeah, this is log of 1/4. Yeah, R must be less than 1/4. R must be less than 1/4. Okay, so if you're in doubt, you can do this, but it's very, you can just take a simple example like 1 by 16, right? And in that case, log r to the base 1/4 is greater than 1, which means we want r to be less than 1/4, but it cannot be any quantity less than 1/4. Since the log must still hold good, we must make sure that r lies between 0 and 1/4. R cannot be negative, right? Okay, so that's Q. And now let's go one more step further. I think we're almost at the last step, right? So this is S, let's say. So R is this R, which is log of some quantity S to the base 16. Okay, so this must be between this R quantity must be between 0 and 1/4, right? So this must be between 0 and 1/4. Okay, so which means we have S must lie between 16 power 0 and 16 power 1/4. 16 power 1/4 is 2. So S must be between 1 and 2. And what is my S? S is this log of x to the base 116, right? So log of x to the base 16 must be between to the base 1 by 16, sorry, between 1 by 16. 1 by 16 must be between 1 and 2. Okay, now obviously this one side is 1 by 16, the other side is 1 by 256, and you can clearly see this is bigger. As long as it's sandwich, doesn't matter, you can easily figure out the signage. So x must lie in this interval. Okay, and then what does he want? He wants the length of this interval, is it? If m and n are a relative prime, what is m plus n? So the length of this interval is how much? Length of this interval is 1 by 16 minus 1 by 256, which is 256 base a denominator, I mean. So 16 minus 1, which is 15. So it's 15 by 256. Clearly 256 is a power of 2, nothing to cancel, and 15. So this is m by n, and then he wants m plus n, which will be 271, 15 plus 256. Okay, it's fairly clear. The only key step is this guy. I mean, figuring out that if it's less than 1/4, that's not enough. It also has to be greater than 0. Other than that, it's always like one inequality. But whenever you have the threat of that quantity going less than 0, you have to put that restriction also. So it gets sandwiched between 0 and something else. Okay, so again, not a complicated problem as long as you know how log works. It's fairly straightforward. It's just a bit laborious. Again, I took time to explain step by step. When you do it quickly, you'll just put your hand here and there and then quickly do it, right? I don't have to be as elaborate when I'm doing it in the paper. So I expect the same of you, right? It might seem like it takes 10 minutes to describe, but if you actually do it, 2 minutes, 3 minutes max. Okay, that was question 7. Let's go on to next one. Okay, is that question 8? Okay, so I have ABC, angle C is 90 and AB equal to 12. Okay, so let's draw a picture. So this is ABC. So this is angle C is 90. So this is 90. AB is 12. And then ABXY and ACWZ are constructed outside the triangle. So ABXY. So let me just construct ABXY here outside the triangle. So X is somewhere here. Y is somewhere here. So this is that square. And then there is ACWZ, which is here. So all of these points lie on a circle. So ABXY and ACWZ all lie on a circle. Okay, so the circle passes through this, and this. So which means the first business should be to identify the center of the circle. Since these x, y, and wz will be the chords, the meeting point of the perpendicular bisectors of the chords will be the center, right? So the perpendicular bisector of this will be halfway through the square. And obviously it'll pass through the midpoint of AB. Similarly, it'll be here. So the center is clearly at the midpoint of the hypotenuse. And you guys know that, let's say this is O. Okay, so if I have the midpoint of the hypotenuse, then the radius just becomes half of the hypotenuse. So you can clearly see that this length and this length, all of these lengths will be same. And he has given the hypotenuse is 12. So this is 6, this is 6, this is 6. And therefore this length is 12. So this big square is 6 and 12. So what is the circle's radius? Circle's radius is going from here to here. O to X. So you have a 6 here. So you have a 6 and a 12. So it's a circle. So it's something like this, right? So you have a 6 here and you have a 12 here. So it's 1:2 ratio. Therefore, this will be root 5. If I take 6 common outside, it's 1 square plus 2 square. So for the radius becomes, OX becomes 6 root 5. So that's the same radius everywhere. And then we have to find the perimeter of the triangle. So let's call this is AC, right? AC is small b, right? This is small b, and this is small a. You label the circle, label the sides with the opposite angle. So we know that a square plus b square is my 12 square. Okay, and the other Pythagoras theorem says if I have this connection from here to here, oops, from Z to O, so that has to match. So this will be what? This is B everywhere. This is B, 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 and this is A by 2. This is A by 2 by midpoint theorem. So we have, and this is B by 2. So we have A by 2 plus B, the whole square, plus B by 2, the whole square, should be the circle square, which is 6 root 5, the whole square, the radius square, 6 root 5 whole square. Okay, so let's simplify this. I have a square by 4 plus 2 times a by 2 times b, which is ab, plus b square by 4 equal to 6 root 5, the whole square, which is 36 times 5, which is 180. Okay, and meanwhile, I know a square plus b square equal to 12 square. So I can combine that as much as possible. So this is a square plus b square, which is 12 square. So 12 square divided by 4 is 36. So ab plus b square equal to 180 plus 36, which is 216. Right, ab plus b square is, 180 minus 36, right? 180 minus 36, which is 144. Okay, so this is b into a plus b. Oh, okay. Actually, we can simplify this even further. So, all right, yeah. So essentially, it's solving these two: a square plus b square equal to 12 square, and b into a plus b equal to 144. I can do it in multiple ways, but because this is matching with 144, it's maybe I can just simplify this very easily. So a square, ab plus b square is your also a square plus b square. In this case, it just so happens, not always, right? Therefore, I can just cancel my a square and ab. I can cancel my b square and a equal to b. A equal to b, therefore, a equal to b, therefore, this is 2a square equal to 12 square. And therefore, a is 12 by root 2, which is 6 root 2. So I can just quickly do a simple sanity check. 6 root 2 whole square, which is 36, plus 36 times 2, which is 72, plus 72 is indeed 144. Yeah, you can just do a simple sense check. So 6 root 2 is your side, and then that, oh, actually it's a, therefore it turns out to be an isosceles right angle triangle. So after doing, we can realize it's an isosceles right angle triangle, but when we start to do it, we don't know that. So 6 root 2, and therefore the perimeter is 6 root 2 plus 6 root 2 plus the 12, which is 12 plus 12 root 2. Yeah, very, very straightforward question. Nothing too exotic here. Yeah, Manan, were you able to get this one? Question 8 was fairly okay, right?
I didn't get this one, but I understood.
But it makes sense, right? You agree it's fairly straightforward, right?
Yeah.
For an AMC12 level, it's fairly straightforward. Okay. Question 9 was a good one. Let's do, okay. Let me see, we have 5 minutes, right? So I want to do something which is doable within 5 minutes. Okay, fine. Let's do question 9, no problem. Okay. Yeah, question 9 is an interesting one. Is anyone able to get this one? Question 9. Anika, were you able to do this?
No, sir, I didn't.
Okay. Okay. So one big hint is logarithms is there, and then he's asking product of solutions. So clearly quadratic, right? Somehow you have to bring in that connection. And whenever you have logarithm, log of product is sum of the logs, right? All of those concepts we should have in the back of our mind, right? Log A plus log B is log of AB, and then Vieta's formula, right? Quadratic sum of roots, product of roots, all of that will come. So suppose there's a product of the roots for x of the solution of the equation, sorry, 8 log x, blah, blah, blah. Okay, so let's write it out properly, right? So what do I have? I have 8 log x. I'll write it as log x by log m times log x by log m. Okay, minus 7 log x by log n minus 6 log x by log m by change of base rule equal to 2013. Okay, so let me multiply throughout by, I'll multiply throughout by log n log m. If I multiply throughout by log n log m, then it becomes 8, and I'll call, let log x be equal to, let log x, I'll just call log x as y or something. Log x is y. So it becomes 8y square, okay, minus 7 log m times y, and then minus 6 log n times y equal to 2013 log n log m. Okay, now essentially we have an equation 8y square minus something into y. So that something is this. I'll just call it b, right? Fine, I don't want to introduce another variable. Let's just call it 7 log n. So 7 log m plus 6 log n, 6 log n y. Okay, and then this big clunk here, right? Minus this entire beast, right? I'll just call this something, right? Equal to 0. So this is the quadratic that we have, right? Now, what do I want? So he says the product of the solutions for x. So let's say let's say alpha and beta are the roots of this equation. Okay. Suppose the product of the solutions for x is the smallest positive integer, which means he's saying product of solutions for x, right? So product of the solutions for x. So log x. Okay, so log of alpha. So the two roots are log alpha and log beta. The two roots are alpha and beta, right? The two roots are alpha and beta. Therefore, in terms of y, that's log alpha and log beta. So alpha beta is minimum, right? Which means log of alpha beta is minimum, right? Because log is a monotonic function, right? If the product alpha beta is minimum, the product of the solutions is smallest. I'm saying alpha and beta are the roots, right? And alpha beta is the minimum, which means log of alpha beta is minimum, which means log alpha plus log beta. Log of alpha beta is log alpha plus log beta, right? Log alpha plus log beta is minimum. Okay, log alpha plus log beta is minimum. But what is log alpha and log beta? Those are solutions of this equation, because y is your log x, right? Which means for this new equation, in terms of y, the sum of roots is the minimum, right? So we want the minimum sum of roots. So the sum of roots is minimum. Okay, so what is the sum of roots? Minus b by a. So 7 log m plus 6 log n by 8. Okay, so that is my log of alpha beta, or rather log alpha plus log beta. So this is the minimum. So which means I'll take 8 this side. Okay, so which means all of you following along, right? If any doubt, please stop me, guys. Which means I'll take this as log of alpha beta power 8 is this, right? So which means alpha beta power 8 is m power 7 into n power 6. Okay, so alpha beta is m power 7 into n power 6 whole power 1 by 8. And we want as minimal value for this as possible. It doesn't help that minimum also has just nothing but m's and n's. So when I write minimum, I get confused with m and n. Okay, so this alpha beta will be minimum. So which means as small values for m and n as possible, right? Such that this whole power 1 by 8 is a smallest positive integer. So this product of roots must be an integer, right? Which means let's choose, so since this is power 1 by 8, so obviously we have to choose m and n as small numbers. So you don't want to choose 3 or 4 or 5. You want to choose the smallest positive integer greater than 1. So let's say m is 2 power, some power of 2, so that it matches this, right? So that when with a power of 1 by 8, it cancels out to give an integer. So let's say this is power a whole power 7, and let's say this is 2 power b whole power 6 whole power 1/8. This must be an integer, right? Which means 7a plus 6b must be, so 7a plus 6b upon 8 must be an integer. So 7a plus 6b upon 8 must be an integer. So let's write out the multiples of 7, 7, 14, 21, 28, blah, blah, blah. Let's write out multiples of 6. So 6, 12, 18, 24, and so on. Okay, so what combination? We'll keep trying. Just a bit of a, obviously it has to be an even number, right? Otherwise it won't give a integer. So we can ignore 7 pretty much and ignore 21. 14 plus 6 is not working out. 14 plus 12 is not, 14 plus 18 is working out, right? So a can be 2, a can be 2 and b can be 3, right? And that's your, that combination works. 14 plus 18 is 32, which is a multiple of 8. Okay, and the question is not a and b, but m and n. So m is therefore 2 power 2 and n is therefore 2 power 3. So we have 8 and 4 respectively, or 4 and 8. And what is the value of m plus n? It's 12. Yeah, definitely a difficult question, but it's putting together all of these concepts together, right? Each of these concepts individually is easy. Logarithms, addition, logarithms, or how we do our manipulation, all that we know. Sum of roots, product of roots also we know. It's just collecting everything together and bringing it. But does this explanation make sense? Pritisha, were you able to do this one?
Yes, sir.
Okay, wonderful. Anyone else? Rahil, is this clear to you?
Yes, I got it.
Okay, cool. So let's stop here. Today was an hours class. So we have homework 4 to discuss, and then we have a few problems in this left. And then I think that I remember there was one more problem in homework 2, which was pending as well. Okay, so the next few days, obviously, a lot of hard work is needed, guys. Your school exams are all mostly over. So plan to spend a lot of time doing as much old paper problems as possible, in addition to the homeworks I assign you.
So I want to ask, like, specifically what should we like focus on the few days before the exam, because like reviewing new like old paper problems, or like just timing like given a fixed set of questions is.
Yeah, I would say both, right? You should work on speed and also, yeah, review like specific topical questions, right? So geometry, permutation, combination, quadratics, all of that, right? So I'll be giving a mix of questions over the next few days. So if you can just focus on those, in addition to if you're able to find extra time, do that also. Yeah, sounds good. Okay. I'll see you tomorrow, guys. Whatever time I've put it on the timetable. I don't remember often. I think it's in the afternoon. Okay. All right. I'll see you then. Bye.
Thank you.
Okay, sir.